Yo guys, welcome back to the series. So, in this episode, we're gonna be, in this part of the series, we're gonna be making a GUI. So, obviously, if you look at my screen right now, I'm on Windows 7, and there's a GUI. It's not just a console. It's not MS-DOS, and even with MS-DOS, there's a GUI if you ran certain applications. But, we're gonna obviously want a GUI in our operating system. There's a few things we do take for granted, like it's sort of hard to explain. For example, when I move my mouse, as you can see, my mouse it removes. So this will be easier to understand when we actually start making the GUI. But like, if I move my mouse, what it does is it deletes its old position off my screen and replaces it with whatever's behind it, which happens to be my Visual Studio, and then it draws itself again in its new position wherever I move the mouse to, if that makes any sense. And you know, it might not, because, and I wouldn't blame anyone if they didn't understand that, because we just take a lot of things in the GUI for granted. It's really a complicated thing to do, but we'll be starting it in this part of the series today, in this video, and we'll actually get a lot done. So, disclaimer, I'm not a graphic designer. I'm not a really artistic person at all. So, I mean, you can, after you watch this video, you'll probably understand completely how to draw your own things, so you could just fiddle with it on your own. And believe me, you'll have a lot of time to do that, because it is a pretty tedious task in some cases, but we'll try our best to make it easy. So anyway, I'm going to right click my practice OS right here, press add new folder. You guys can't see it, but I'm right clicking my practice OS right here. I'm clicking on add, and then it opens up something else, and I could click new folder. And I'm just gonna call this one GUI. I don't want to call it GUI actually, because that's gonna be a name of the class. I'll just say graphics. And or no, screw that. I'm gonna call it UI. And now what I'm gonna do is say, I don't even want to call it UI actually. I'm gonna call it graphics. And now what I'm gonna do is add a class to it. Just right click on this new folder, add new item, and I'm gonna call this one GUI. That's why I didn't want to call it GUI, because you can't. I don't really want it to the folder name to be the same as the class name. But anyway, just gonna add it in the GUI class right here into this folder, and just set this up. Oh, I like it. And we're gonna do some imports. So go up here using cosmos.system.graphics. That should be pretty self-explanatory. It's just the graphics namespace that helps us with graphics. System.drawing. This is just so that we can access our handy things that we use in other C# applications, such as points, rectangles, that kind of thing, those kind of structs. We're going to import the sys equals cosmos.system. If you don't remember, if I go to my kernel, it's this right here. It's that. We've imported it in file, I believe. We imported it there. So we're just going to import it again here for the same here for the same reason. And finally, just going to import cosmos.system. Whoops. Because, we're going to need a few functions, or a few methods in that class as well. And the way you make a GUI is you need a class called canvas. So we're going to create one of these canvases. And I'm going to create a GUI constructor here for our class, and then and the constructor will initialize the canvas. And the way you initialize it is you say full screen canvas, which is just a class in cosmos.system.graphics, and then it's got a static method called get full screen canvas, and it does exactly that. It gets the full screen canvas so that you can create a canvas for your full screen on your operating system. And now we can do many things with it. We can clear it. That's the first thing we're going to do, I think, here. So, you know, whatever you want the background of your operating system to be, color.black. I completely forgot to actually put the method in though. But in there, you just put your system.drawing.color black or whatever you want your background to be. And the next thing we're going to do is create a pen up here, and this is another system.drawing thing. Or no, wait, no, this isn't. This is a cosmos.system.graphics thing. And basically what this pen is for so that we can draw like what we're actually going to draw on our GUI. So whatever we're going to draw is going to be in the color of the pen. So whatever you want the color of your actual things on your GUI to be for now, you could change it, but like just for now we're going to make it 2 colors just because I don't really want to make anything really pretty right now. I want to make it functional. So just set the pen to whatever color you want. Make sure it's not the same as your canvas color that you cleared it as, and you're good. So anything we draw is going to be in this color of this pen. And now we got to do a few things. So there are a few things we want to keep track of in our GUI. So I guess what we can do for now is just keep track of the mouse state. So I'm going to create a mouse state variable up here, and this I'll just call it previous mouse state actually. And we're just going to set it to mouse state on none right here, because obviously there's going to be no previous mouse state since we're only just creating the GUI. And we don't want it to be null, because that's going to cause us problems. And we're also gonna initialize the mouse, this is kind of weird way to initialize something, or like not weird, but just it's not the same as a lot of different ways you initialize things. Like for example, I initialized a new pen here. I initialized full screen canvas here. I initialized our canvas here. As you can see, those are 2 different ways you can initialize things. But the way you actually initialize your mouse is kind of weird. It's different than all these other ways that we've used. So we're going to select the mouse manager class in cosmos.system. And you're going to see there is no way you can initialize it apart from this, which is kind of unexpected. What you have to do is select the screen height and set it to the height of your screen. And the way you figure out the height of your screen in a canvas is you check the rows. So I'll write it down first. And the way that you could see rows is that, rows are what go down. Because there's rows and columns. Rows go down. They're vertical. My bad. I meant they go horizontal. They go left to right, or right to left. And the reason it's called rows, you can think of it as 1 pixel is 1 row, or like 1 row of pixels is 1 row. So it's basically the height. It's the height of your canvas, and the canvas again is like your full screen canvas is what you get to draw on. It's your GUI basically. And it's gonna throw me an error right here. Cannot implicitly convert int to uint. So we could just convert this to a uint just by casting it. And the reason that I can just cast it without checking anything is because your rows are always going to be a positive number, and the only real time we're gonna get an error with this is if we try to if this was negative or above a really high number, then it would cause an error. But this is always positive because it's the height of our screen, so it's always gonna be positive. It can't be negative, and it's not gonna be like an absurdly high number. So we could just safely cast it to a U integer with unsigned integer without any real worries. And we're not actually done. We gotta do the same thing for the width. So yeah, now we're just selecting the columns and setting it to the width. So this is actually how we initialize it. We've now initialized the mouse. We've initialized the mouse by typing these two lines, and I know it's a bit strange to anyone who hasn't initialized something that way before. But that's literally it. We've initialized it now. But the problem is we haven't drawn where the mouse is. So although it's like keeping track of where the mouse is for us, we're not doing anything with it. So the way we're gonna do that is we're gonna create a public void handle GUI inputs. And I'm gonna need to make a few variables here. So the first thing we're gonna do up here is say private uint32 unsigned integers. We're gonna create px and py. The reason that I named them this is previous x and previous y, so we can get the x and y values of the mouse on the previous frame. And the reason we do that is because of this. Look, if this dot px is not equal to mouse manager dot x, and this dot py is not equal to mouse manager dot y, then we'll move the mouse. And what this is we're just checking if the mouse has moved. Because if the mouse has moved, then we're actually gonna draw the mouse again. Because if we don't do that, the mouse is gonna be blinking and it's gonna be like updating the mouse for no reason because it hasn't moved. So why would it need to update it? So just to explain this, we're checking if the previous x on the previous frame of the mouse is equal to the current frame mouse x, and same for y. And if it's not, then we're actually going to move the mouse. So basically, just to be clear, if code here runs, then the mouse has moved since the last frame. And now a thing in Cosmos is that, or in your canvas, is that if you try to draw something outside of the bounds of this screen, it's gonna crash your complete operating system. So the way we're gonna stop that is we're gonna say if your mouse manager dot x is less than 2, or if the y is less than 2, then we're not gonna run. We're gonna return and not move the mouse. We're not moving the mouse if it's trying to go off the screen. Because if it goes off the screen, our entire operating system will crash. Because it's gonna try to draw pixels off the screen, which is obviously impossible. But this only works for the top of the screen because we haven't actually checked if it goes off the right or bottom of the screen. But just so that you guys understand this, if you look at my mouse right now, it is in the top left of my screen, and right now its position is 0, 0. And now I'm gonna move my mouse down here. I don't actually want to show my desktop, so I'm not gonna put it there, but right now my mouse is at like 1980 x and 1260 y or something like that. And so basically, if your mouse goes to the right, the X goes up, and if it goes down, then the Y goes up. And that's why we're checking if it's in the right now we're checking if it's reaching the far left of the screen or the top left, or the top of the screen. But now we have to check if it reaches the bottom or right side of the screen. So the way we do that, we check if the X is greater than the screen width minus 2. So the screen, let's say the screen width is 1280. If you look at my mouse right now, you kind of really can't see it, but it's on the right of my screen. And right now my mouse is at 1280x. And now that I moved it a little bit to the left, it's now at like 1260. So we need to just check if it's going off to the right because the screen width, the variable, is the max value of x. So we want to check if it's reaching the right of the screen. And now, do the same thing for y. And now we basically, just to be clear, if the mouse tries to go out of bounds, don't move the mouse. It'll just completely stop this function entirely, this entire handle GUI inputs, if the mouse tries to go out of bounds. So that way our operating system won't crash. Now, if you do recall, we made some variables, this.px and this.py, but we never actually set them. So this.px equals mouse manager.x, this.py equals mouse manager.y. We can now safely set these variables because we've used them, how we need to use them, right up here. And the reason we don't put it here is because we want to make sure that the mouse isn't going out of bounds before we set it, because it can't go out of bounds. So if we set it, then it would be set at a position that the mouse can't go. And now what we're gonna do is we're gonna set the design of the mouse. And the way I'm gonna do that is by creating a bunch of points. And the way we create a bunch of one type of variable, obviously, is by making an array. And the way we're gonna initialize this array actually is by putting down 2 squiggly brackets and then a semicolon. And now in here, we could type what we want to add into our array. So for example, the first thing in our array is going to be a new sys.graphics.point. And then we'll set to mousemanager.x and mousemanager.y. Whoops. And what this is going to do is draw a point exactly where your mouse is. But as you guys can see, but if you look at my mouse right now, it's not one point. It's not one pixel. It's a whole, picture, basically. It's a whole icon. It's not just one pixel on the screen. So I'm going to add a little bit of a design to it, but first, as you can see, it's giving me an error. This is just because it wants integers instead of unsigned integers. It's kind of weird that how they made the mouse manager variable as unsigned integers, but they made the point normal integers, but it's fine. We could just cast it easily. It's not that big of a problem, as I explained earlier. And the way we add a new point is we add a comma to the end of this one. And now we can go on the next line. We don't have to go on the next line, but it looks better. So we're going to go on the next line and make our new point. And from this point on, you could design the mouse however you want as long as you understand my explanation of this. But let's say we want a pixel. Let's say we want to make a cross. So we're going to make a cross here. And the way we make a cross is obviously, or by cross I just mean like a plus sign. Oh, and the way we're going to do that is obviously, I'll just explain this MS Paint. So, right now, with just this one point, our mouse is going to look like that. Just a dot. Well, it's going to be white, but you know, because we made our pen white. But, now, I'm going to make a point right here. That's just one to the right of the mouse manager X. So now our mouse is going to look like that. There's going to be one pixel drawn to the right of the mouse. And if we want to make the plus sign, then we're going to need one above it, one to the left, and one under it. So the way we do that, make a new point. So one to the left of it, we just reduce the X by 1. We want to go 1 under it, so we 1 down, so we increase the Y by 1. And obviously we want to go 1 above it, so we decrease the Y by 1. And we actually haven't drawn the mouse yet. We've only made the points that we want to draw the mouse at. So what we're going to do is loop through every single one of these points. And the reason I'm typing sys.graphics.point is because if I just type my normal point, you're going to notice that it has an error. And the reason it's an error is because there's two different types of points. There's a system.drawing.point. But then, you know, we don't want that point because that's not what the canvas uses. It uses system.graphics.points. Or if you like it better, you can also do this. Cosmos.system.graphics. But like I don't really see why you want to do that if you could just do that. And now what I'm doing here, I'm looping through every single point in the array we just made. So for every point in the array we just made, it's going to go through every single one of these points. And you could add points. You could design your mouse however you want as long as you have an understanding of what I just said. And what we're going to do is draw the point at the, using the canvas. This.canvas.draw point. Oh, and also we want to use our pen. So we just select our pen that we made earlier. That's whatever color. And now you'll notice that what we've done is we've now made 1, 2, 3, 4, 5 points, and now we're going through every single one of those points and just drawing a pixel at each of those points. But it might seem like it's gonna work right now, but it's not, because basically it's not gonna remove the old precursor. So basically it's just gonna be like a paintbrush. It's gonna, if you move your mouse, it's just gonna draw on the screen. This is kind of hard to explain without showing you guys, and I really can't because it would take a while. But say that right now I'm not clicking, I'm just moving my mouse, and say that this canvas is my operating system. This is what it would look like. It would just look like that as I'm moving my mouse without clicking or anything. Because what we did is we didn't replace the pixels before it. So it's not going to remove the old mouse position. It's just going to keep drawing it as I move my mouse. And you know, it's not that hard to fix. All we're going to want to do is save the pixels that our mouse was on top of before. So we're going to go up here, private, and we'll create a list. And what we're going to need to save is not only the position of the old pixel, but the color that was behind the cursor. So the way that we store two classes is we use a different class called tuple. And you could use tuple to store 3 different kinds of classes, 4, 5, 6, and so on. And the way that you use it is you just put one of these brackets and you just say the 2 different classes you want to store. And as I said, we want to store the position of the cursor, or of the pixels, so we use point, and then the color, and we'll just call it save pixels. And the way that we save them, or first I'm gonna go up here and just initialize it. So since I'm here, I'm just gonna set px to 3 and this dot py to 3. And the reason I'm doing that is because, as you remember, I'm checking if the mouse goes out of bounds. So we don't want it to start out of bounds, we want it to start inbound, so we're gonna set it to 3. And then we'll just initialize saved pixels, and it should do it for you if you just press enter, but that's the code if you want to just copy it off. And now, the way that we're going to save them is we're going to go back to where we draw the pixels, which is right here. And before we actually draw it, we'll save it. So this dot save pixels dot add, and then we'll add all the information we need. So the way that we create an instance of a tuple is we just say new tuple with the 2 points, or the 2 classes, and then in brackets here you put the value for these 2 classes. So the point is right here. It's very easy for us. But to actually get the point's color that's at that pixel, we have to write this dot canvas dot get point color. And then I'm gonna write p dot x and p dot y, because it's just the x and the y of the point. And the get point color, all it does is it gets a pixel on the screen at 2 coordinates, and the coordinates are of the point, and then it will just return a color, a system.drawing.color. Whoops. Now we're not done, because although we have stored the pixels, we need to actually restore them. So simply all we do before we draw them, before we draw the mouse, what we're gonna do is loop through every tuple, and we'll call it pixel data, because technically all this tuple is the pixel data. It contains the x, y, and color of the pixels, so I'm just gonna call it pixel data in the list I just made. And now we'll just draw a point, or this dot canvas dot draw point. We'll restore it just by giving it its old color and old everything back. And the way we do that, so the way what I'm doing is I'm creating a new pen, and a pen takes a color. So basically you could just consider this the color. And to get the color, all I have to do is take pixel data and type dot item 2, because as you'll see, this right here is item 1, the point, and this right here is item 2. So we'll get the color of it just by selecting item 2 variable, and then the second argument is the point. So we'll select item 1 to get the point. And actually we're done, so yeah, I'm just gonna get rid of this. The only thing we actually have to do is get rid of the old pixels that were saved before we, like in the previous frame, and that's so easy to do. All we have to do is clear them. There's just a handy method in lists that does it for me. That's why I love lists so much. I love the entire system.collections.generic namespace. And there's other reasons I do as well, but that's besides the point. Let me just look, see if there's any obvious errors here. Yeah, it looks fine. There's not much going on. But as you guys remember, we did add something called previous mouse state, and so what I'm gonna do is just detect if the user has clicked. So I'm just gonna go after our statement here, because as you guys remember, this right here runs if the mouse has moved. But if the mouse hasn't moved, or if it has moved, it doesn't matter, because all we're doing is checking if they're clicking. You know, if I'm just keeping my mouse still and clicking, it's still gonna register the click, obviously. And if I'm moving my mouse and clicking, it's still gonna register the click. Obviously, that's how operating systems work. So we're not gonna wait for the mouse to move before we let it click. So we're just gonna skip this entire if statement. The only situation where the mouse, where it won't accept a click, is if it returns here, and it returns if it's trying to move out of bounds, and there's nowhere you could click out of bounds anyway, so it doesn't matter. So now what we'll do, the way we do it is we just check if the current mouse manager mouse state is equal to mouse manager left. Mouse state left. And we'll just do console.b system.console.b, because there's also like Cosmos console, but we're using the system console. And the thing is, if you hold your mouse down, it's still going to be beeping, because as you see, we're checking to see if the left button is down. So if I hold my mouse down, it's just going to continuously beep if I run this code. And the way that we check if the mouse has just clicked is we need to do this. We need to set the previous mouse state and what we're going to do is also check if the previous mouse state is not mouse state.left. So this is just going to ensure that you're clicking down instead of holding down the mouse button. So hopefully this is pretty self-explanatory, but like I'll go over it one more time. It's checking if you've pressed the left button, and it's checking that to make sure you weren't holding down the left button in the last frame. So to simplify, it's checking to make sure that you're not holding down your mouse button and you're only clicking left click like once, not holding it down. This looks good to me. But, you know, actually, no, we haven't actually drawn anything on the screen apart from our mouse. So that's what we'll do. I mean, we've created this entire folder, so yeah. I'm just gonna right click my folder, add new item. Like you right click your folder, then there's an add, it says add, you click that, and then it opens up a new thing, and you could click a new item. And then you simply write down, what we're gonna do is we'll draw a tab bar. We'll draw a tab bar, And the reason we're making this as a new class is because we're not only going to be drawing it, we're going to be making like buttons and stuff, and we just want to make it really simple. So we're just going to add it to our all to one class, and we're just going to create that. And this is kind of, I'm just going to be completely honest, I'm just going to do this lazily, because it's just your tab bar. There's nothing really. I'm just gonna hard code everything here instead of like actually trying to design a lot, because there's not gonna be many elements to it, but it'll work completely fine, so don't worry about it. And the first thing we're gonna do, same thing. We're gonna create a pen. Well, whoops. Obviously, we're gonna have to import a few things. The same things we did before. Actually, I think that's all we really need. And now, since we're not actually in the GUI class, we're not going to have direct access to the canvas. So in the constructor, we're going to ask the user to give us the canvas we want to draw the tab bar on. And since we're not going to keep the canvas because it belongs to the GUI, we're just going to store the information about it, like rows, columns, as we were storing it before. And by the way, guys, in case you forgot, whenever I'm typing like int32, it's the same thing as int. Whenever I type uint32, it's the same thing as uint, and so on. But back to what I was doing. What we're gonna do is just set the pen to whatever color you want your tab bar to be. And then we'll just store all the information about the canvas the same way we did before. But now we want to actually draw stuff on the screen. So the way we do that, I mean, this is going to be kind of hard to imagine in your head, but we're going to draw a rectangle. Yeah, we'll draw a rectangle at the bottom of the screen, because I'm just looking at my tab bar right now. It's at the bottom of the screen. It's not called tab bar, but like our operating system doesn't really have like applications in Windows and stuff, so we're just gonna call it the tab bar. And we'll just draw a rectangle at the bottom of our screen. So obviously we want the top left bit to be at the first pixel, so we'll set it to. Oh, first of all, actually, we'll select the pen that we just made, so that it could be white. And now, we're going to just select the leftmost part of the screen, because if you look at your own, if you look at my mouse here, as you can see, this whole start menu thing, it starts at the left of this screen. So the way that we get the leftmost point is at x equals 0. And I'm just gonna put all zeros right now, because so that we can fill them in. And the next thing it's gonna ask you is for the Y. So we'll make it go 100 from the bottom of the screen, 100 pixels from the bottom of the screen. And if you guys remember, this dot rows is equal to the y-axis of your screen, and the y-axis is, and the highest possible y-axis on your screen is the bottom of your screen. So we want to go 100 from the bottom of our screen. The way we do that is we just take 100 off the bottommost part of our screen. And the second one, we'll make it go 2 pixels to the off the right of our screen, just to make sure that my operating system doesn't crash. I don't know if I need to do this, but like I don't want it to crash, because like I kind of want to do this in one go, so I'm just gonna be safe and take it 2 pixels off the right of the screen. And for the for the height, we'll make it 99 instead of 100, because I want it, again, I don't want it to like go out of bounds and crash my GUI and crash my operating system, because I don't want to have to be sitting here and debugging during the video. And now I kind of just have an idea that what we're gonna do later is make it so that you can open up an instance of our console, like our, like we were able to write commands in that console in our operating system. I want to open that up on our GUI, so I'm just gonna right here quickly just draw a simple thing that you can click on that will I'm just gonna make it like a little 100 by 100 box, and I'll draw a slash through it. Yeah, I'll draw a little bit of a slash. Whoops. Yeah, that's a little bit of a slash. Should be pretty good shape, and now what we're gonna do is, since I said that the tab bar is gonna have buttons you can click on. Well, we'll create a we'll create a little bit of a function or method that will try to process clicks on the tab bar. And it's just going to take in the location of the mouse, that wherever the mouse was clicked at. And what we'll do, what we're going to do is we're going to create two rectangles. And the first rectangle is just going to be the mouse X, the mouse Y, and it's just going to have a size of 1 pixel, width and height of 1 pixel. And the reason that I'm doing it for making a rectangle even though it's 1 pixel is because it has this really handy function called intersects with. And I don't know if there's a better way to do this, but I've just used this function before, so I'm gonna stick with what I know. And the next thing is actually gonna be a rectangle, and I'm just gonna make it of the box I just made. And yeah, I'm just gonna set it to the exact same size as the other box. So what we're doing here, just to explain this, we're creating a new rectangle with a size of 1 pixel at the mouse coordinates that were clicked at, and we're checking if that's inside of a button that I made up here. And the button is just, we're not gonna make it do anything right now. I'm just gonna make it beep. But like later in probably maybe next video, I'm gonna make it like open up a console window so that we could type in our console commands. And finally, I'm gonna go back to my GUI. And I'm just gonna make the thing. I'm gonna add in the tab bar. Private tab bar. And in our constructor here, we'll just go this dot tab bar equals new tab bar. And and then we're gonna say our canvas. Just make sure you put it after your canvas is initialized. And basically, whenever this line is run, it's going to draw all the rectangles we set to draw on the screen. So this is going to draw a rectangle on the bottom of the screen, draw a square on the bottom left, and draw a slash thingy, I don't know, a slash character. Not really a slash, I don't know if it's going to come out good, but like it's going to be somewhat of a slash character inside that square. And yeah, so all of that is gonna happen when this is run. So now I think this is good. Yeah, this is all good. I'm gonna go back to my kernel now. Kernel.cs. And I kind of want to do the least as possible in here, so that's kind of why I made all this. Because I kind of just want to keep my kernel really neat, because I just want to be a well-structured application, but we still have to do a few things. Like, first of all, we gotta import the GUI we just made, so then you just want to go up here, type using, and then whatever namespace you have. As you can see, mine's practice OS dot graphics, because that's what I named the folder, or whatever you named your folder. And now we'll be actually able to put down the GUI. We'll create a private GUI. But as I said, whenever we do this, if I were to do this, then that means that the GUI would be created, and my application would be a GUI. I wouldn't even have an opportunity to type in any commands or anything. So what I'm gonna do is just create a command. I'm just gonna call it launch GUI. It's just gonna be very simple. I will go back to my kernel. I'm gonna make this public. And I'll make it static. I think, yeah, I'll make it static. And that way we'll just be able to access it from anywhere. Now we're gonna go back to my command, and I'm just gonna make it like a normal command, as we did it twice before now. So I don't really need to explain that much, but we're just making it a command by doing that, and then we're adding the required constructor, give it a name, and then we're gonna now give it like a function so I can actually do something. The response is should be launch GUI. I'm not really gonna care about that too much, because obviously when the GUI is open, like you're not gonna see the response. But anyway, this dot. What I'm gonna do is say, because I said we're gonna create our console in the GUI, I'm gonna check the kernel and say if the kernel.gui is not null, then return a response of you are already in GUI. Otherwise, we're gonna set the GUI, and we're gonna have to import it really quick, as we did in kernel. And now our GUI is launched. Now the only thing is, if you guys remember, we made a whole function called handle GUI inputs. We've actually never used it. So where we have to use it, all I'm gonna do is go into our run function. I'm gonna say if the GUI is not null, that means that we're in our GUI. So I'm gonna just stop everything else, don't do anything else, because we're in our GUI. So why would we do all this with the console? We're in our GUI, because if it's not null, that means it's open. And we're gonna, or not this.gui, kernel.gui.handle GUI inputs. So yeah, then that's the extent of how much we have to use the kernel. It's not much, so I'm glad it's not much, only 4 lines in that, but still. We're gonna go to my command manager and say this.commands.add new GUI, or launch GUI. You call it launch GUI, you call it GUI, anything you want really in this string. Just make sure the class name isn't GUI, because then it's gonna get confused with the graphics one. Maybe, it depends. But like, just don't do it, because we don't want to. It's not a good idea to have 2 classes with the same name. It's just kind of messy and stuff. And yeah, you don't have to change this to 3, but I forgot to change it and it still worked. But like, you know, it's saves a weeny bit of time if we set it to 3. Or whatever the size of, or however many commands we have. Because, you know, I had it at 1, I didn't even notice, and it had 2 commands, and it was working fine. That's why I like lists as well, because you don't have to give it a size, you could just, you know, just add in as many as you want. All it has to do is resize itself, which does take a little bit of processing power, but since we set in the capacity of 3, it doesn't actually have to resize itself. So it's just completely fine. I didn't mean to do that. Look for any really obvious errors here. Oh my god, IL2 CPU is now taking 48 seconds. That's now 18 seconds on what it above what it used to be when we first started. And that's not even including the other things that has to happen. It just doesn't really give us much of a time stamp. Yeah, this is taking longer too. I remember it was like at, I think it was like at 18 even. So god damn, that's a lot of time. Now I might as well check if I'm recording still. Yeah, I'm recording. If you don't change anything and you re-debug, it's gonna launch a lot quicker than if you did change something and you try to debug it. But anyway, launch GUI, and okay, wow, okay. So as you can see, we have I'm not in the operating system, that's why you can see my mouse, but we have the slash. It looks really good. And we have the rectangle I made at the bottom of the screen and the square I made. They're actually overlapping each other right now that I look at it, but it's not that big of a deal. And now I'm gonna please work, man. Okay, well, okay, so yeah, the mouse is working fine. As you can see, it's working fine up here. There is a little bit of lag. If the lag, I don't think it's much to worry about unless it increases over time. If it increases over time, then there's an issue. That means you like forgot to clear a list or something. I don't think it is. I think the only reason it's lagging is because of isn't really much, you know, I don't have much CPU or processing power on this virtual machine. It lags on whenever I use it on Windows as well, even harder, like so much harder. I can hardly run it. But anyway, what I haven't tested is if I go over this line, if it's gonna return it to white pixels. It is. And you know, you might look at that and take it for granted, be like, oh, okay, it's setting the white pixels back. Well, it actually is a pretty big deal. Just trust me. Like it's kind of hard to do. Yeah, it works fine. And now, oh my god, I forgot to do something. I just clicked and did not expect that. I don't know if you guys can hear that, but it's beeping. So what? I completely forgot to go in my GUI. I know what I did wrong. Right here, I made it so that if you click, it's just gonna beep. What we actually have to do is select our tab bar and then try to process the click. Even though that this runs, no matter where you click on the screen, we're still gonna do it because we're not that advanced right now. And all I'm gonna do is just passing the X and Y, and wait for it to debug again, and then hopefully I can close out this super long video. It's already been, I think, almost an hour, so I mean, I try my best to make short videos, but I always get carried away because I try to explain things as best I can. Because, you know, if you just watch someone program and you don't really understand what's happening, you're not gonna really learn. You gotta like kind of try to figure out to do things on your own, or you gotta like get the explanations. So yeah, just take it from me. You guys should try to do things on your own, even if it's like a complete failure. You gotta learn eventually. So, you know, just try to figure things out on your own. Whenever there's an error, the first thing you should do is try to figure it out yourself, because you know, you can't like you can't always go on like Stack Overflow to like look up errors. And it's actually like really satisfying if you figure out errors on your own and you make like a really complex application without any online help. Like, I've done all of this so far with hardly any help apart from like the documentation, which is, if you look on like the documentation of something, that's completely fine. Like, it's there for a reason. But like, if you're just copying people's code and stuff and just asking people for help all the time, you're really not ever gonna learn, and you gotta just kind of like try your best to learn. It's my advice for everybody. Because, you know, the mouse manager, the only thing in the documentation for the mouse manager example, for example, was set the screen height and screen width to initialize it, and use mouse manager.x and y for the x and y. That's all that was on the documentation. It was like one sentence. So, you know, sometimes there's not a lot of information about something, and if you don't really have a good understanding of C#, then you might not be able to figure it out. Like, and for graphics, the only documentation for the GUI, it said like how to make pixels and rectangles and stuff. So all of this like wasn't on the documentation. But anyway, okay, I'm clicking right now. It's not beeping now. It's the moment of truth. Okay, it did beep. Let me just see here. I'm clicking around it. And the one last thing we did is we wanted to check if the mouse can go out of bounds. So fair warning, if I crash here, it might crash if I mess something up. Let's see. Okay, so it's not going up, and it might lag a little bit because like the mouse like skips ahead a little bit, but yeah, as you can see, it's not going up. Like, I'm dragging my mouse up right now, and as you can see, it's teleporting a bit, but like it's not that big of a deal. At least the mouse can move around fine, and it can't go out of bounds. Like, it does not go out of bounds. As you can see, it went right to the edge there. It just doesn't go out of bounds. But this video has been long enough. I'm getting carried away here. I'll see you guys in the next video. I respond to every question, so if you have one, I literally respond. You know, like, it's not an inconvenience to me or anything to answer your question. Like, I'll help you as best I can. So yeah, if you have any questions, just let me know.